According to the National Electrical Code, specifically NEC 250.142b, a cold water pipe shall be bonded to the grounded conductor, which is the neutral, if it is used as a grounding electrode. Additionally, NEC 250.53 states that a grounding electrode conductor, or GEC, shall be connected from a system grounding electrode, such as a ground rod, to a point on the grounded conductor, the neutral, inside this service equipment. The rationale behind this bonding is primarily for safety. Bonding the cold water pipe provides a low resistance path for fault currents to return to the source, significantly reducing the risk of electrical shocks. Furthermore, establishing a solid connection between the cold water pipe and the neutral conductor ensures a stable reference point for neutral voltage, preventing voltage imbalances and potential equipment damage. There is a valid concern that a bonded cold water pipe can provide a parallel path for unbalanced load currents. However, this concern is typically insignificant in residential and light commercial applications where imbalanced loads are usually not significant. The primary function of the cold water pipe is to provide a reliable path for fault currents, which are typically of short duration and high magnitude. Unbalanced load currents, on the other hand, are typically of lower magnitude and longer duration. Regarding additional considerations, the bonding connection should be made as close as possible to the point where the cold water pipe enters the building. The grounding electrode conductor should be of adequate size to carry any potential fault currents. The integrity of the bonding connection should be periodically inspected and maintained to ensure a reliable path for fault currents. In conclusion, based on the NEC regulations and practical considerations, it is generally recommended to bond the cold water pipe to the neutral and install a grounding electrode conductor from a ground rod to the neutral in a 120 volts 2-wire system. This provides both safety and stability for the electrical system. While the concern about a parallel path for unbalanced load currents is valid, it is typically not a significant issue in typical residential and light commercial applications. Let's delve deeper into the specific requirements and best practices for bonding in a 120 volts 2-wire system, ensuring compliance with the National Electrical Code and prioritizing electrical safety. Firstly, the purpose of bonding is to create a low impedance path for fault current to return to the source, which in turn facilitates the rapid operation of overcurrent protective devices, such as circuit breakers or fuses. This is essential to minimize the duration of a fault and reduce the risk of electrical shock or fire. Secondly, the grounding electrode system, which includes the ground rod and the connection to the cold water pipe, serves to stabilize the voltage to ground and provide a reference point for the electrical system. This helps to prevent voltage fluctuations and reduce the potential for electrical noise. Thirdly, the size of the grounding electrode conductor is critical and must be selected in accordance with NEC Table 250.66, which takes into account the size of the service entrance conductors. Using an undersized conductor can compromise the effectiveness of the grounding system and increase the risk of electrical hazards. Fourthly, the bonding jumper connecting the cold water pipe to the neutral bus must also be adequately sized, typically based on the size of the service entrance conductors, and should be installed close as possible to the point where the water pipe enters the building. This minimizes the impedance of the bonding path and ensures effective fault current clearing. Fifthly, when installing a ground rod, it should be driven into the ground to a depth of at least 8 feet. And any necessary connections should be made using approved methods and materials such as exothermic welding or listed grounding clamps. These connections must be mechanically sound and corrosion resistant to ensure long-term reliability. Sixthly, it is important to note that the cold water pipe can only be used as a grounding electrode if it is in direct contact with the earth for at least 10 feet. If the water pipe is interrupted by insulated couplings or non-metallic sections, it cannot be used as a grounding electrode, and an alternative grounding electrode, such as a ground rod or ground ring, must be installed. Seventhly, in addition to bonding the cold water pipe, it is also important to bond any other metallic piping systems that may be present in a building, such as gas pipes or heating ducts, to the grounding electrode system. This helps to prevent voltage differences between these systems and reduce the risk of electrical shock. Eighthly, it is crucial to ensure that all bonding and grounding connections are properly tightened and protected from corrosion. Periodic inspections should be conducted to verify the integrity of these connections, and any signs of corrosion should be addressed promptly. Ninthly, the neutral conductor, which is the grounded conductor, should be insulated and sized appropriately for the load it is intended to carry. It is important to avoid overloading the neutral conductor, as this can lead to voltage imbalances and potential equipment damage. Tenthly, when working on a 120 volts 2-wire system, it is essential to follow all applicable safety precautions, including de-energizing the circuit before making any connections, using appropriate personal protective equipment, and verifying the absence of voltage with a reliable voltage tester. In addition to these specific requirements, it is also important to understand the general principles of grounding and bonding. Grounding is the intentional connection of a neutral conductor or equipment enclosure to the earth, while bonding is the connection of metallic parts to form an electrically conductive path. The purpose of grounding is to stabilize the voltage to ground and provide a reference point for the electrical system, while the purpose of bonding is to create a low impedance path for fault current to return to the source. Both grounding and bonding are essential for electrical safety and must be performed in accordance with the National Electrical Code. Let's discuss the common misconceptions about grounding and bonding in 120 volts 2-wire systems. Firstly, one common misconception is that the ground rod is the primary path for fault current to return to the source. In reality, the ground rod primarily serves to stabilize the voltage to ground and provide a reference point for the electrical system. The primary path for fault current is the bonding conductor, which connects the equipment enclosure to the neutral bus. Secondly, another misconception is that it is acceptable to use the neutral conductor as a grounding conductor. This is not permitted by the National Electrical Code, as it can create a shock hazard. The grounding conductor must be separate and distinct from the neutral conductor. Thirdly, some people believe that bonding the cold water pipe is unnecessary if a ground rod is installed. However, the cold water pipe provides a supplementary grounding electrode and helps to reduce the impedance of the grounding system. Both the cold water pipe and the ground rod are important components of the grounding system. Fourthly, there is a misconception that grounding and bonding are only necessary in new construction. However, grounding and bonding are also important in existing buildings to ensure electrical safety. Older buildings may not have adequate grounding and bonding systems, and it may be necessary to upgrade these systems to meet current code requirements. Fifthly, some people believe that it is acceptable to use undersized grounding and bonding conductors. However, undersized conductors can compromise the effectiveness of the grounding system and increase the risk of electrical hazards. The size of the grounding and bonding conductors must be selected in accordance with the National Electrical Code. Sixthly, a common misconception is that ground fault circuit interrupters, or GFCIs, eliminate the need for grounding and bonding. While GFCIs provide protection against ground faults, they do not eliminate the need for a properly installed grounding and bonding system. GFCIs and grounding and bonding work together to provide comprehensive electrical safety. Seventhly, some individuals mistakenly believe that simply driving a ground rod into the earth is sufficient for grounding. The effectiveness of a ground rod depends on the soil conditions and the depth to which it is driven. In areas with poor soil conductivity, multiple ground rods may be required to achieve adequate grounding. Eighthly, a misconception exists that all metallic objects in a building must be grounded. While it is important to bond metallic piping systems and equipment enclosures, it is not necessary to ground every metallic object. The focus should be on creating a lower impedance path for fault current to return to the source. Ninthly, there is a belief that plastic piping eliminates the need for grounding. While plastic piping is non-conductive, it is still important to bond any metallic components that are connected to the piping system, such as valves or fittings. Tenthly, a misconception is that electrical tape is sufficient for making grounding connections. Grounding connections must be mechanically sound and corrosion resistant, and should be made using approved methods and materials, such as exothermic welding or listed grounding clamps. Finally, It is essential to stay informed about the latest updates to the National Electrical Code and any local amendments that may apply. The NEC is updated every 3 years, and it is important to ensure that all electrical work is performed in accordance with the current code requirements. Always consult with a qualified electrician or electrical inspector if you have any questions about grounding and bonding.